Now that we know what an exponential is, if you have a function like 3 to the power x, then this x which we have is known as the index or the exponent. And this 3 which we have is known as the base. Therefore, the 3 to the power x is the one that is called an exponential. Is that fine? So let us continue. From here, we're going to wrap. We're going to talk about roots. Rules for indices. So what are these rules? We realize that for us to solve anything that is involving the indices, we still have rules to guide us, or the rules that are going to show us on how we're supposed to go about. So the first one that we have is x to the power n multiplied by x to the power m. This only tells us that if our base is the same, then we're supposed to add the exponents, which is going to be x n plus m. So what if we are dividing? If we have x n divided by x to the power m, this simply implies that this is going to be x n minus m. Then the third one that we have is where we have x raised to the power n, then everything is raised to the power n. This simply means that we are supposed to multiply the powers which we have this side, which is going to be x n m. And from this, what we have, we can look at some of the examples. So let us look at examples. So if the first one we have square root of, if we have 2 raised to the power 3 multiplied by 2 raised to the power 4. This is going to be easy for us, right? So this is just going to be 3 multiplied by 4, which is 2 raised to the power 12. Then, again, we have something on division, of course. If maybe we have, so we consider this one to be the first one, then we have the second one. If you have 3 to the power 6 divided by 3 to the power 4, this simply means that this is going to be 3, 6 minus 4, which gives us 3 to the power 2, which we can even find the value for this 3 to the power 2 as well as this 2 to the power 12. So let us look at different examples. So I'm still going to wrap this part. If we have something that is a bit different, maybe if you have, okay, so we are going to consider this to be the third example. If you have 27 to the power 2 over 3, and you've been asked to find this, what are we going to do? Because when we look at this, this simply means that you have 27, then we have a 3 here, and we have 2. Do we agree with that? Then, if we find the cube root of 27, it's going to give us 3. Because when you raise 3 to the power 3, it's going to give you 27. Which simply means that this 3 which is down is going to be the cube root of what we have inside. So if we find the cube root of 27, it's going to give us 3. But we have these 2. So these 2 which we have, we're not going to raise this 3 to the power 2. And when we find 3 raised to the power 2, this will just give us 9. And we are done. So what if maybe we also have other questions where we are asked to find the values of the first one, where we consider this one to be A, where we have 100 raised to the power 3 over 2. Then on B, we have something like 32, which is raised to the power negative 2 over 3. How are we going to solve this? So we're going to pause a minute before we find the solution, for you guys to try out the solution. So let us continue. So if this is what you have been given, we're still going to use the same idea and the same concept which we have above. So this is going to be, we have a 2 here because that is what we have done. Then we have 100 raised to the power 3. So when we find the square root of 100, this gives us 10 raised to the power 3. And when we find the value of 10 raised to the power 3, this is going to be 1,000. Then let us look at this other one. We have 32 raised to the power negative 2 of 3. What are we going to do with this? This is a negative sign that we have for the power. So the first thing that we are going to look at is for us to change this negative power into a positive. So this is going to be 1, then down we have a 3, then we have 32 raised to the power 2. So we need to find the cube root of 32. And from here, when you find the cube root of 32, that is just 2. So this is going to be 1 over the cube root of this is 2, which is raised to the power 2. Then we have 1 raised 1 being divided by 4. That's all, and we are done with that. Then we're going to move and look at other questions. So I guess you guys have seen this because I'm going to rub it out. Something else. If maybe you are asked that if you're asked to show that, then the first one you have 3 to the power 2x minus 1 being equated to 9 power x over 3. Then the second one we have 2 raised to the power x minus 1 multiplied by 8 raised to the power x plus 1 equal to 4 raised to the power 2x minus 1. That's 1. If this is the questions that we've been given and we've been asked to show, so we want to show this 3 raised to the power 2x minus 1 that it is the same as 9 raised to the power x being divided by 2. That is our focus. So with this, from the rules that we looked at, we are told that if the exponents are subtracting, it simply tells us that somewhere we are dividing the bases. So we are still going to use the same concept. So from here we're going to consider the left hand side. So we'll consider the left hand side to make it be the right hand side because that's the one that seems to be easy for us to do. So we have this 3 2x minus 1. So from what we have here, we realize that we can actually get this, which is now going to be 3 2x being divided by 3 to the power 1. Then from what we have here, again we are going to look at other properties that we looked at, or the rules that we looked at when we are considering multiplication. It simply tells us that the powers somewhere they were multiplying each other. So this simply means that this is 3 raised to the power 2, then outside we have x, then divide by 3 to the power 1. Then from what we have here, this is 3 raised to the power 2 is going to give us 9 raised to the power x. Then we divide with 3 raised to the power 1. We're going to continue. So this is just 9 raised to the power x. Then we divide with 3. And we get what we wanted to get. And we're good to go. The second question. Well, we have. So we're also going to consider the left hand side to make it to be the right hand side. So here we have 2x minus multiplied by 8x plus 1. So this is what we have, and want to get this, which we have on the other side. So from what we have, we can still write this in some way. So we have 2x minus 1 multiplied by, when we look at 8, we can also change the base, so that we're trying to simplify, so that it's going to be of the same base of 2. So here we're going to have 2 raised to the power 3, and it's multiplying with x plus 1. We see that. Then from here, we're going to have 2x minus 1 multiplied by 2 to the power 3x. Then we have plus 3 on the other side. So from what we have here, we can still collect the like terms together. We can add and subtract some things. So we have 3 to the power x minus 1. What does it tell us? So we'll pause a minute. I want you guys to think, or now we can expand this and the other side. Then we'll continue from there. So okay guys, we'll continue from where we ended. I asked you guys to think and see what you're going to get. So let us continue with that. When we look at this and what we have on the other side, the bases are the same. So we're going to deal with the exponents just by adding them, of course. So on the next step, we're going to have 2, then we have x minus 1 plus 3x plus 3. So from what we have down here, we're going to have 2x plus 3x, we collect like terms, of course. This is going to be 4x. Then we have negative 1 plus 3, which gives us plus 2. And from what we have here as the exponents, we can still factorize something. So this is going to be 2 raised to the power 2. Then we have 2x plus 1. Then from there, this is 2 raised to the power 2. Then we have the other one. So 2 raised to the power 2 gives us a 4, which is raised to the power 2x plus 1 as our final answer. And we are done with that. So now that we've done some examples, I'm not going to give you questions which you're going to try out. So we're going to have an exercise. So we have the task. And the first question is, show that for the first one we have 3 minus x, which is equated to 8 over 2 raised to the power x. Then the second one we have 16 raised to the power x, which is equal to 4 raised to the power 2x. Then we have the third one, which is 4 raised to the power 2 minus x being equal to 16 over 2x. And we have the not the last, actually number 4. I'm going to give you 5. 2 raised to the power 2x plus 3, which is equal to 8 times 4 to the power x. Then the fifth one, which is the last question, we have 5x multiplied by 25 to the power y being equated to 5x plus 2y. Simple, right? So this is your task. I want you guys to solve these questions, then we'll continue from there.